I have a chat. Yes, exactly. The keyword is proportion. Excellent. Perfect. So let us begin. (6.3) Confidence intervals for the population proportion. Recall the probability of success in a single trial of a binomial experiment, which is P. We defined it in chapter 4. And we said that, hey, Q is 1 minus P. This probability is a population proportion. In this section, you will learn how to estimate a population proportion, P, using a confidence interval. As with confidence intervals for mean, you will start with a point estimate. The point estimate for P, what is P? P is population.
Sorry, I didn't find the lectures on the module.
So the point estimate for P, population proportion of successes, is given by the proportion of successes in a sample, and it's denoted by P hat equals to X divided by N. We call it sample proportion. So P hat equals to X divided by N. What is X? X is the number of successes in the sample, and N is the sample size. So N is the sample size, and X on top is the number of successes in your sample. Well, the point estimate for the population proportion of failures is Q hat, which is 1 minus P hat. The symbols P hat and Q hat are read as P hat and Q hat. Very well. So example, in a survey of 1,000 US teens, so you have 1,000, you have a survey. When you have a survey, it means that you're working with a sample. What's the sample size? 1,000 or N. So quickly form your fraction. P hat is equal to 1,000. The sample size goes on the denominator. 372 said that they own smartphones. So 372 is your X, and it goes on top. 372. This is my point estimate, which is sample proportion. So N is equal to 1,000. x is equal to 372. Your p hat, as we calculated that, x divided by n is 372 divided by 1,000, or 0.372. And you can leave it as percent or decimal. Both of them are fine. 37.2%. So the point estimate for the population proportion of US teens who own smartphones is 37.2%, or just 0.372. Let us go over one checkpoint. So let us read this and identify the numbers and see what do we have. In a survey, again, you have a survey, it means that you have your sample. If it says census, it means that you're working with population. Since it's a survey, it means that we have a sample. A sample or survey of 2,462 US teachers. So this is your sample size, N. If I want to construct my p hat or my point estimate or sample proportion, this is equal to x over n. I have my n, which is 2,462. This guy goes on the denominator, 2,462. 123 said that all or almost all of the information they find using search engines online is accurate or trustworthy. 123 is your x, the number of successes, which is 1, 2, 3. Let us do the calculation. What is the decimal, or what is this division between 123 by 2,462? What is this decimal number? .05. Very good. The rest of the class. Very good. Thank you, thank you, thank you. 0. Almost 0.0. Can say that, hey, this is approximation, estimation. So you can say that, hey, 0.05, excellent. Very well, everyone. Thank you so much for 5%. Well done. So we have the proportion or point estimate for these two examples. Let us move on to the next page. On page 2, constructing a confidence interval for population proportion P. So guys, for population, we don't use any hat. It's just P itself. So constructing a confidence interval for a population proportion P is similar to constructing a confidence interval for population mean. The process, the instruction, all the same. You start with a point estimate. Your point estimate is going to be P hat, and you calculate the margin of error. Then you say that, hey, P or population proportion is bounded between P hat minus margin of error and P hat plus margin of error. To find margin of error for P or population proportion, we use ZC. ZC means that you're using your Z table or inverse. Norm for 1 minus C divided by 2. guidelines. Identify the sample statistics n and x. Find the point estimate p hat x divided by n, like we did before, like we did in these examples and the checkpoints. We found p hat by dividing x over n. Sometimes it's given in the question and we don't have to do any algebra. Verify the sampling distribution of p hat can be approximated by a normal distribution by checking these two conditions. The sample size times p hat is greater than equals to 5, and the sample size times q hat is greater than equals to 5. Well, now you find the critical value, ZC, using Z table or inverse. Norm 1 minus C divided by 2. Then you find the margin of error, E, which is ZC, times square root of P hat, Q hat, divided by N. Remember that Q hat is 1 minus P hat. After you find P hat, you can quickly calculate Q hat, which is 1 minus P hat. Then find the left and right endpoints and form the confidence interval. So your population proportion is between P hat minus E and P hat plus E. We can use our calculator to verify that we have a correct confidence interval. We go to stat, we go to tests, and we need to find one proportion Z interval. One proportion Z interval. Then enter the values of X, the number of successes, N, the sample size or the total number of values in your tries, and C as the confidence level. Then calculate, and it gives you the lower bound and upper bound for population proportion. Very well. So let us go over the first example on page 3. Question says, construct a confidence interval for population proportion. Guys, when you don't see any hat, it is population proportion. Question says, use the data in example in page 1 to construct a 95% confidence interval for the population proportion of US teens who own smartphones. Very well. So what are the steps? Let's go to the board, write down the information that we have. Erases. So page 3, example. So what information is given to me? What do I have? In page 1, the information that I have are you can use chat, you can unmute yourself, very good. P hat, very good. I have my P hat, which is point estimate, which is given as point. We calculated that, x divided by n It was, let me see, 372 divided by 1,000. We calculated this together and we got 0.372. This is your point estimate of the sample. So what do I need? Check the first step. Yes, p hat is x divided by n. I have my point estimate. Next step, I have to check to see the normality is met or not. And p hat is greater than or equals to 5. So this is my first step. P hat, I found it, 0.372. The second step, I need to check to see if n times p hat is greater than or equals to 5. And I also need to check to see if n times q hat is greater than or equals to 5. So I can go to the next step. What is n? N is 1,000. 1,000 times p hat, 0.372. It gives me 372, which is greater than or equals to 5. I'm happy about that. How about the second condition? In q hat. What is q hat? 1 minus p hat. Q hat is 1 minus p hat. The probability or proportion of failures, like binomial distribution. So q hat in this case is 1 minus my p hat, 0.372, which is equal to, what is your q hat?
0.628.
Very good, 0.628. This is your q hat. So 1,000 times 0.628, which is 628, greater than or equals to 5. I'm happy. The normality condition is met. Let us move on to step 3. What is my ZC? What's the confidence level that you have? The confidence level is 95%. 0.95.
1.696.
Very good. ZC is 1.9, 1.90.
96.
Very good. Now next step is to find margin of error for E equals to ZC, which is 1.96 times. Guys, here you have to use square root. Square root of what? P hat, Q hat. P hat is 0.372. All of them are inside the radical, times Q hat, which is 0.628, divided by n. N is 1,000. Please do the calculation. Give me the value that you have.
Professor,
Yes.
could you please go over again, like why we got 628, like why we did that to get 628?
So remember in binomial experiment, in chapter 4, they had P, which was the probability of success. Probability of success. Then we said that, hey, we have probability of failure as well, which was Q 1 minus P. Here is the same. Your P is 0.372 or 37.2%. So you have your probability of success or your sample proportion 0.372. What is Q hat? 1 minus P hat. 1 minus 0.372, which is equal to 0.628. P hat, 1 minus P hat, which is your Q hat. These are the information that we have. Q hat. The probability of failure. Is that clear for everyone? Make sense?
Yeah, I got it. Thank you.
Perfect. So what's the estimation here? 0.03. Nice, excellent. So approximately we have 0.03%, give it or take. Next step, construct the confidence interval. 5 confidence interval is P hat minus the margin of error, comma, P hat plus the margin of error. Okay, let's construct that confidence interval. P hat 0.372 or 37.2% minus 3%, comma, 0.372 plus 0.3%. So what's your lower limit? What's your upper limit? The confidence interval is approximately. If you do that, you get 9, 369, and 0.375. What's the meaning of that? It means that we are 95% confident that the population proportion what we were looking for, the proportion of US teens who owns smartphones, population proportion of US teens who owns smartphones is in between 36.9% to 37.5%. Is it a good thing or is it a bad thing?
Good thing?
Please fix that. It's 0.342. Let us take a look at the calculator. Okay, here we go. So you go to stat, you go to tests, and you need to find one proportion Z interval. Let's enter. So your X in this example is 372, and your N is 1,000. Confidence level is 95%. Let's do the calculation. So we get 34.2% to 40.1%. This is what we got from our example as well. Let me show you one more time. Okay. You go to stat, you go to tests. Now you need to find one proportion Z interval. One proportion Z interval. Enter. Our X was 372. Our N, or the sample size, was 1,000. Confidence level, 95%. And here we go. You can always check your work, use your calculator. So this example says The figure at the right is from a survey. Very good, survey. It means that we have a sample of 498 US adults. 498 US adults. So, is this X? Is this N? What is this? You have a survey of 498 US adults. Is this your sample size or is this your X? The number of
Sample
samples.
size.
N.
It's N. Excellent. N is given to you. N is 498. Perfect. Construct a 99% confidence interval for the population proportion. Population proportion is P of US adults who think that teenagers are the more dangerous drivers. We have a figure. We have who are the more dangerous drivers? Teenagers, 71%. What is 71%?
P hat.
P hat, excellent. P hat is given to you. You don't have to calculate P hat. So P hat or 71% is 0.71. You can calculate your Q hat, which is 1 minus 0.71. Remember that Q hat is 1 minus P hat. 1 minus P hat is 0.29, or Q hat is 29%. Okay, let's go to the board. Write down this on the board. Have to follow the instruction. So page 4. What is our P hat? Do we have to construct the P hat or is it given to us? What is your P hat? P hat is
1%.
very good. You have 71%. You don't have to construct that. P hat is
Sorry,
given.
it's not clear right now.
P hat is given to us. P hat is given as 71%. So what is your Q hat? 1 minus P hat. Q hat is 1 minus 71%, which is 29%. 0.71. Check normality. N times P hat must be greater than 5. N times Q hat must be greater than 5. What is N? What's your sample size?
498.
98. Excellent. 498. So is 498 times 71% greater than equals to 5? Is 498 times 0.29 greater than equals to 5? Do the multiplication. What is this multiplication here? What is this multiplication here? What do you have? $353.58. Okay, thank you. Almost 353, so greater than equals to 5. I'm happy. The second one, 144. Thank you. Almost 144, which is greater than 5. I'm happy. So these two are met. We can move on to finding ZC. What is your C? C is 90, how many percent?
99.
99%. Very good. So what is your ZC for 99%?
2.532.
2.575. Very good. 75. Remember that you can use your Z table or inverse norm. And what is your margin of error? ZC 2.575 times square root of P hat 71% times 29% divided by N. What is N? N is 498. What is your margin of error, guys? 0.20, 0. The rest of the class. What is our margin of error?
0.052.
Very good. 0.052, or you can say that, hey, this is 0.05. So confidence interval is P hat minus E, P hat plus E. My P hat is 71% minus 5% at 71% plus 5%. So confidence interval is equal to 0.66 and 0.76.
I use calculator is a 0.6564. It's okay?
Yeah, of course, close enough. So we say that we are 99% that the population proportion. But what is population proportion? Population proportion of US adults who thinks that teenagers are the more dangerous drivers of US adults who thinks that teenagers are dangerous drivers is in between 66% to 76%. Is between 66% to 76%. Let us take a look at our calculator. So very well, turn it on, go to stat, go to tests, one proportion Z interval. So I have, let me see, what is my X? In this case, I can say that. So what is your X? What number you enter here? What is your X, everyone? How do you calculate your X? Let me show you. You have 71% of 498. X is equal to 71 times 498 divided by 100. 100. That's how you find your X. What is this number? 350. This is your X.
The 354. I
Yes.
use the 353.
353, 354. Both of them are fine. And N is 498. Confidence level 0.99. Let us do the calculation. Very good. You get 0.66. If you want to round it, you get 0.66 to 76%. Perfect.